Hello there and welcome back to the Sleep Science. You're here again, drifting in that in-between space where curiosity hasn't quite powered down, but the day has finally loosened its grip. You imagine yourself standing outside at night, cool air brushing your skin, the moon hanging there like a quiet observer that's been watching humans far longer than you've been watching it. It looks calm, harmless, almost decorative. Yet tonight you're going to entertain the idea that it's been meddling with your sleep all along. Yes, your sleep. The one you thought was being ruined solely by caffeine, deadlines, and that one neighbor who seems to vacuum at midnight. You probably won't survive this with your illusions intact. For centuries, people have blamed the moon for strange nights, tossing, turning. I'm waking too early with thoughts that feel louder than they should. Modern life has taught you to roll your eyes at that kind of talk. You're scientific now. You've got blackout curtains and a phone that tells you exactly how poorly you slept. And yet, here you are, listening because some stubborn data refuses to behave. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, maybe post where you're listening from and what local time it is, just to remind yourself how wide awake or how close to sleep you really are. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start by noticing the moon the way humans always have, as a light source. Long before LEDs and alarm clocks, moonlight mattered. One mainstream historical fact that often gets overlooked is that pre-industrial humans experienced brighter nights during full moons, enough to extend evening activity. Historians know this because court records, work logs, and even crime reports from medieval Europe show spikes in nighttime activity around full moons. People stayed up later because they could see. No mystery there, just photons doing their thing. But sleep, as you're learning, is rarely that simple. You imagine yourself lying down in one of those earlier centuries, straw mattress beneath you, window open, moon spilling pale light across the room. No blackout curtains, no glowing phone screen, just your brain trying to decide whether it's time to power down. Some researchers suggest that this ancestral exposure might have trained human biology to anticipate lunar cycles, a kind of evolutionary memory that never quite got deleted. Historians still argue whether this influence was strong enough to shape long-term sleep patterns, or whether humans simply adapted behaviorally without changing underlying biology. Either way, the argument refuses to go away. Now for a quirky tidbit, because sleep science always has one hiding under the bed. In the 18th century, certain European almanacs included lunar sleep warnings, advising lighter meals and calmer evenings during full moons. This wasn't poetry or superstition alone. These guides were practical household manuals, sitting next to planting schedules and medical advice. Imagine checking the moon phase before deciding whether to nap. You chuckle, because you barely checked the weather before complaining about it. As you settle deeper, you notice how the conversation shifts from folklore to lab coats. Fast forward to the 21st century, where researchers tried very hard to kill the moon myth. One famous modern study found that participants slept about 20 minutes less and took longer to fall asleep during full moons, even though they had no windows and no idea what the moon was doing outside. That's the part that makes you squint at the ceiling. No moonlight. No expectation, just a subtle change, as if your brain had received a memo it wasn't supposed to read. Skeptics pointed out the small sample size and supporters nodded grimly, because small effects are exactly what biology loves to hide behind. You shift in your imaginary bed as gravity enters the chat. Yes, watch that gravity, the same force that pulls oceans into tides. You've probably heard someone say, with great confidence and very little evidence, that the moon's gravity pulls on the water in your body. Scientists agree on one thing. The gravitational effect of the moon on a human body is minuscule compared to everyday forces. Standing up changes gravity's pull on you more than the moon ever will. And yet, some researchers speculate that sensitive biological systems, like circadian timing mechanisms, might respond to rhythmic gravitational changes in ways we don't fully understand. Historians still argue whether it's even reasonable to compare ocean tides to human physiology. But the idea refuses to sink. Your thoughts drift to circadian rhythms, that internal clock ticking away in your brain's suprachiasmatic nucleus. It doing its best to keep you on schedule. You know it responds strongly to light, especially blue wavelengths. Moonlight, though much dimmer than sunlight, has a spectral quality that early humans experience regularly. Some chronobiologists suggest that the moon may act as a weak but consistent timing cue, more like a background metronome than a command. Not loud enough to wake you, but persistent enough to nudge. It's the biological equivalent of that one song you didn't realize was stuck in your head until it wouldn't leave. Here comes another small joke, because even in sleepy science, you need a breather. If the moon really is controlling your sleep, it's doing a remarkably subtle job. No evil laugh, no on-off switch, just a gentle cosmic shrug. You imagine the moon saying, "I didn't make you binge watch that series. I just made it slightly harder to stop." As you breathe slowly, you also breathe in the uncertainty. This field is full of it. Historians still argue whether reports of lunar sleep disturbance in ancient texts reflect real physiological effects or cultural storytelling amplified over time. Were people actually sleeping worse, or were they just talking about it more? Modern science hasn't fully answered that either, because measuring sleep is messy, human behavior is messy, and the moon, frankly, refuses to cooperate by changing its schedule for experiments. You feel your body growing heavier now, the way it does when curiosity starts to blend into calm. You haven't been asked to believe anything yet, only to notice, to allow the possibility that something ancient and distant might still whisper to your nervous system, even through concrete walls and glowing screens. The moon doesn't need to dominate your sleep to matter. Sometimes influence is quiet. Sometimes it's just enough to tilt the night by a few minutes, leaving you wondering why you're awake, staring at the ceiling, thinking about tides and ancestors and that one almanac that warned you to eat lightly. And with that thought gently looping, you let your attention soften, knowing there's more to explore, but no rush at all. The moon isn't going anywhere. You don't wake up so much as you drift forward, carried from that last thought about almanacs and moonlit windows into a much older world. Here, the moon isn't a background decoration. It's a calendar, a clock, and occasionally a bossy supervisor. You picture yourself thousands of years ago, standing with others under a sky so dark it almost hums. The moon bright enough to cast shadows sharp as cut paper. Sleep in this place isn't something you schedule with an app. It's something you negotiate with nature. Ancient civilizations paid close attention to lunar cycles, and not just for romance or poetry. One mainstream historical fact is that the Babylonians divided time using the moon, carefully tracking its phases to organize agriculture, religion, and daily life. Clay tablets show lunar calendars etched with obsessive precision. Nights weren't all equal, and everyone knew it. Full moons meant extended activity, rituals, work, travel, while darker nights encouraged earlier rest. You imagine yourself lying down later than usual, muscles tired but mind oddly alert, because the night simply refuses to feel finished. While your thoughts wander to ancient China, where lunar calendars also ruled. Sleep was woven into yin and yang rhythms, with the moon associated with yin, cool, receptive, inward. Some traditional medical texts suggested that full moons stirred internal energies, making rest lighter and dreams more active. Historians still argue whether these ideas reflected real observations of sleep changes or symbolic philosophy layered onto ordinary experience. Either way, people noticed patterns, and they talked about them enough to write them down. Here's a quirky tidbit that feels almost cinematic. In parts of ancient Greece, temples dedicated to Asclepius practiced incubation sleep, where people slept in sacred spaces hoping for healing dreams. These rituals were often timed with lunar phases, especially the full moon. Imagine lying on a stone floor, incense in the air, moonlight slipping through columns, convinced that tonight, because of the moon, you might dream more clearly. Placebo effect, spiritual framework, or an early attempt to harness a rhythm humans sensed but couldn't yet explain? Take your pick, or keep all three. You notice how often the moon shows up wherever sleep and meaning intersect. In Roman times, writers like Pliny the Elder commented on lunar influence over moisture, growth, and even mental states. Sleep wasn't isolated from these ideas. It was part of a larger web connecting the body to the sky. Historians still argue whether such writings were observational science or educated speculation, but the confidence is striking. No one laughed at the idea that the moon mattered. It would have been like laughing at gravity, unthinkable, and probably hazardous. As you settle deeper, you realize something important. Ancient people didn't separate psychology from environment the way you do now. If the moon changed behavior, more gatherings, more rituals, more noise, sleep would naturally change too. Staying up later wasn't insomnia, it was participation. This makes you wonder how many lunar sleep effects were actually social effects wearing a cosmic costume. Modern researchers still debate this exact point, asking whether biology or behavior did most of the work. Your breathing slows as you drift into the medieval world, where monasteries tracked lunar cycles alongside prayer schedules. Monks rose for night prayers, and moonlit nights made these vigils easier and longer. Records from monastic communities show subtle shifts in sleep timing depending on lunar brightness. Again, nothing mystical, just practical adaptation. But over generations, these shifts became normalized, baked into expectations of how nights felt. Historians still argue whether repeated behavioral changes like this could subtly tune circadian systems over centuries, leaving echoes in modern humans. Now comes a gentle joke, because even monks would probably appreciate it. If your sleep schedule had to obey both God and the moon, you'd be tired too. You smile faintly at the thought, then let it drift away. In many indigenous cultures, lunar cycles guided storytelling and communal rest. Some North American tribes held longer evening gatherings during full moons, sharing stories that stretched late into the night. Sleep followed the rhythm of the group. You imagine a child nodding off by the fire, soothed by voices in moonlight, learning without words that some nights are simply meant to be lighter. Historians still argue whether these communal practices affected individual sleep architecture, but anthropologists agree they shaped expectations about night itself. You notice a pattern forming. Wherever humans lived close to nature, the moon quietly structured nights, not with force but with permission. It allowed, it extended, it suggested. And because sleep is as much about expectation as physiology, those suggestions mattered. Your modern brain, trained to dismiss anything without a randomized controlled trial, feels a little less certain now. As you drift, you remember that ancient people didn't have one consolidated 8-hour block of sleep. Segmented sleep, 2 shorter periods with a quiet, wakeful interval in between, was common. Full moons likely stretched that middle wakeful period. You imagine yourself waking naturally at midnight, moon high, feeling calm rather than annoyed. No clock screaming that something is wrong. Historians still argue whether segmented sleep was healthier or simply necessary, but its compatibility with lunar light is hard to ignore. Your thoughts soften further as you consider how these ancient patterns might linger. Evolution works slowly, and sleep architecture is deeply conserved. Even if modern lighting drowned out the moon, the brain's wiring may still expect subtle variation across the month. Not enough to ruin your night, just enough to tilt it. That tilt, multiplied across millions of people, becomes statistically visible and personally confusing. When another small smile crosses your mind, maybe the moon isn't sabotaging your sleep. Maybe it's reminding your nervous system of a time when nights were allowed to be different from one another, when not every evening had to end the same way. You feel yourself sinking now, the past fading into a gentle blur of firelight, stone floors, and silver skies. The moon remains overhead, patient and unchanged, while humans below it shift, adapt, and occasionally lose sleep wondering why. The answer, your learning, might be older than worry itself. You drift forward again, leaving temples and monasteries behind, and suddenly the moon is no longer something you pray to or plan rituals around. Now it's something you try to control for. You picture yourself stepping into a modern sleep laboratory, and I'm the kind that smells faintly of disinfectant and overconfidence. Wires wait on the bedside table like polite spiders. Cameras blink softly in the corners. Outside, the moon might be full, thin, or hiding entirely. But in here, it's been invited in only as a variable. This is where modern science enters the story. Lab coat buttoned, arms crossed, determined to be unimpressed. One mainstream historical fact anchors this shift. The first formal sleep laboratories emerged in the mid-20th century, transforming sleep from a private mystery into a measurable biological process. Brain waves, eye movements, muscle tone. Suddenly your night had charts. And for a long time, researchers assumed the moon had nothing to do with any of it. Artificial light, social schedules, stress, those were the obvious culprits. The moon felt like leftover poetry. And yet you lie down on the lab mattress, sensors pasted to your scalp, and something awkward happens. In several studies, including one that made waves in the early 2000s, participants took longer to fall asleep and spent less time in deep sleep around the full moon. This happened even though the rooms had no windows and the participants didn't know what lunar phase it was. You imagine the researchers frowning at their spreadsheets because science hates surprises that don't announce themselves properly. Historians still argue whether this moment marked a genuine turning point in lunar sleep research or just a statistical fluke that gained attention because it was weird. Replication became the battlefield. Some studies found similar effects, others found nothing at all. Please welcome to the part of science that rarely makes headlines, the slow, patient disagreement. You breathe calmly as you picture the experimental setup more closely. Constant temperature, controlled light levels, strict bedtimes, no caffeine, no alcohol. It's sleep stripped of personality. And that's exactly why the lunar findings, when they appear, feel unsettling. If you remove behavior, expectation, and environment, what's left to explain a pattern tied to the moon? Your brain doesn't answer. It just hums. Here's a quirky tidbit to keep you company. One research team, after failing to find a lunar effect, reanalyzed their data years later and suddenly did find one. Same data, different statistical lens. The moon didn't change, human interpretation did. If that doesn't perfectly summarize science, nothing does. You smile sleepily at the thought of the moon waiting patiently while researchers argue about p-values. As you settle deeper, you notice that modern labs also revealed how subtle these effects are. We're not talking about lying awake all night, howling dramatically. The changes are small, minutes, percentages, slight shifts in brainwave patterns. But sleep researchers know that small changes can matter. Shaving a bit off deep sleep night after night can alter mood, attention, and metabolic health. Historians still argue whether such tiny lunar effects, even if real, are biologically meaningful in the long run, or just curiosities for journals and podcasts like this one. You imagine yourself watching your own brain waves scroll across a monitor. During deep sleep, they slow into rolling hills. During lighter sleep, and they jitter like nervous handwriting. Some studies suggest that during full moons, those slow waves become slightly less pronounced. Not gone, just muted. Like the moon turning down a dimmer switch you didn't know existed. The effect is so gentle you'd never feel it consciously. You just wake up thinking, I'm a bit off today. Another gentle joke drifts through your mind. If the moon is sabotaging your deep sleep, it's doing it with the politeness of someone who rearranges your furniture by 2 centimeters and waits to see if you notice. You think about expectations next because psychology always sneaks back in. Even in windowless labs, participants bring their beliefs with them. Some scientists argue that unconscious awareness of lunar cycles, picked up through media, calendars, or social cues, could still influence sleep. And others counter that many participants couldn't even tell you when the full moon was. Historians still argue whether expectation alone can explain consistent physiological changes across multiple studies. The debate remains unresolved, like a late-night email chain no one wants to end. You shift, imagining the contrast between lab sleep and real sleep. In the lab, everything is artificial. At home, life leaks in. Pets move, cars pass, neighbors exist. If lunar effects are partly environmental, brighter nights, more evening activity, they might be stronger outside the lab. Some field studies using wearable sleep trackers suggest exactly that. People go to bed later and sleep less around full moons, especially in places with lower light pollution. Again, not dramatic, just persistent. All right, your breathing deepens as you picture researchers trying to isolate one cause from another, peeling back layers like an onion that never stops making you yawn. Light, gravity, social behavior, biology. None of them operate alone. Historians still argue whether the moon's role in sleep is direct or emergent, arising from many small influences aligning at once. Maybe that's why it's so hard to pin down. The moon doesn't act solo, it conducts. You also notice how modern skepticism plays its role. Extraordinary claims require extraordinary evidence, and the moon affects sleep sounds extraordinary in an age of blackout curtains and smartphones. Some scientists worry that even entertaining the idea lends credibility to myths about lunar madness and emergency room chaos. But others point out that rejecting data because it feels uncomfortable isn't very scientific either. You nod faintly, half asleep, appreciating the irony. As the lab lights dim in your imagination, you realize that modern sleep science hasn't dethroned the moon. It's simply forced it to behave. No mysticism, no destiny, just small, measurable nudges that may or may not survive the next round of analysis. That uncertainty, oddly enough, is soothing. It means you don't have to believe anything tonight. You can just rest with the possibility. You lie there, wired but calm, moon unknowable but present, as your brain waves slow. Whether the moon is watching you back or not hardly matters anymore. The lab fades, the graphs blur, and you drift onward, carrying the quiet tension between data and doubt with you, like a lullaby sung in numbers. As you drift onward, leaving the humming machines of the lab behind, and now the focus turns inward. This is where the moon's story intersects with the quiet ticking inside your own head. You imagine peeling back the skull, not in a creepy way, keep it PG-13, and finding a clock. Not digital, not even mechanical, but biological. It ticks anyway, steady and stubborn, telling you when to feel sleepy, hungry, alert, or oddly emotional at 3 in the morning. One mainstream historical fact grounds this part of the journey. In the 1970s, scientists identified the suprachiasmatic nucleus, a tiny cluster of neurons in the hypothalamus, as the master circadian clock. This structure coordinates daily rhythms using light as its primary cue. Sunlight in the morning resets it. Darkness in the evening lets it wind down. He's simple enough, until you remember that for most of human history, darkness was never absolute. Moonlight regularly filled the gap. You picture early humans falling asleep under skies where the moon waxed and waned with dependable rhythm. Some chronobiologists suggest that the circadian system might not just respond to a 24-hour day, but also remain weakly sensitive to longer cycles layered on top of it. Lunar cycles don't replace the circadian rhythm. They ride shotgun. Historians still argue whether humans ever evolved a true circulunar rhythm like some marine animals have, or whether any lunar sensitivity is merely a side effect of light exposure and behavior. Here comes a quirky tidbit that feels almost unfair. Certain marine species, like corals and worms, time their reproductive cycles to the moon with astonishing precision. When entire populations spawn on the same lunar night, your brain, by comparison, struggles to remember where you left your keys. And yet some scientists wonder whether fragments of lunar timing mechanisms might exist in humans, faint and unreliable, like an old app still running in the background. You breathe slowly as hormones enter the conversation. Melatonin, the hormone that signals night to your body, is exquisitely sensitive to light. Even dim illumination can suppress it. Full moonlight is much weaker than artificial indoor lighting, but outdoors or in pre-industrial homes, it could have mattered. Studies suggest that brighter nights correlate with lower melatonin levels and delayed sleep onset. Historians still argue whether moonlight alone was ever strong enough indoors to produce this effect consistently. But the mechanism itself is not controversial. You imagine melatonin as a gentle usher, guiding you towards sleep with a soft hand on your shoulder. Moonlight, even faint, taps that hand and says, "Not yet," not forcefully, just enough to make the usher hesitate. In a modern world flooded with light, this lunar nudge might seem irrelevant. But biology doesn't forget easily. It keeps responding to cues long after their original context has changed. Another hormone drifts into view, Cortisol. It follows a daily rhythm, peaking in the morning to help you wake up. Some small studies suggest cortisol rhythms may shift slightly around full moons, though results are inconsistent. Historians still argue whether these findings represent real lunar influence or statistical noise wearing a lab coat. Either way, the idea that the moon could subtly tilt your stress hormones is both fascinating and mildly annoying. You are hoping to blame emails exclusively. You settle deeper as sleep stages come into focus. Your night is not a single state but a cycle. Light sleep, deep slow wave sleep, REM, over and over. Deep sleep restores the body. REM processes emotion and memory. Small shifts in their balance can change how rested you feel. Some research hints that full moons are associated with reduced slow wave sleep, while REM remains relatively stable. Not dramatic, just enough to make mornings feel slightly off. Historians still argue whether this pattern is robust across populations or limited to certain groups. You smile faintly at another gentle joke. If the moon is meddling with your sleep architecture, it has a preference. It messes with your body first and leaves your dreams alone. Consider it in a cosmic sort of way. Now you consider the idea of internal clocks beyond the circadian. Scientists know humans have ultradian rhythms, cycles shorter than 24 hours, and infradian rhythms, longer ones like menstrual cycles. The lunar month roughly matches the average menstrual cycle length, a coincidence that has fueled speculation for centuries. Modern research finds no consistent synchronization, but the overlap remains intriguing. Historians still argue whether cultural observation of this coincidence exaggerated its biological significance. Your breathing grows slower as the idea of timing sinks in. Perhaps the moon doesn't cause anything directly. Perhaps it acts as a temporal landmark, reinforcing patterns already present. Just as weekends feel different because of expectation and habit, lunar phases might subtly frame nights, especially in environments where people still notice the sky. You imagine lying outdoors, eyes half closed, feeling the night air cool your skin. The moon rises, and something in you registers the change. Not consciously, not verbally, but physiologically. A whisper to your internal clock. This is a bright night. Stay alert a little longer. Historians still argue whether such whispers are loud enough to matter in modern humans, but you find the idea oddly comforting. As Section 4 drifts toward its end, you feel that internal clock ticking more softly. The moon doesn't override it. It doesn't control it. It simply brushes against it once a month, like a hand on the shoulder reminding you that time is layered, not flat. A day within month, month within year, sleep within life. You let that thought slow and lengthen, stretching out like a yawn. Your internal clock keeps ticking, steady and patient, while somewhere outside, visible or not, the moon continues its quiet loop, keeping time in a way your body may still faintly remember. You drift onward, and now the conversation takes on weight, literal weight. Gravity slips into the room, not with a crash, but with a polite cough. You picture the moon hanging there, massive and distant, tugging on Earth with a force strong enough to move oceans, but supposedly far too weak to bother with you. Supposedly. This is where skepticism sharpens its knives. One mainstream historical fact sets the stage. Isaac Newton's law of universal gravitation established that every mass attracts every other mass. The moon raises tides because it exerts a differential gravitational pull across the Earth. That part is not up for debate. What is debated, vigorously, is whether that same force could have any meaningful effect on a human body. Most physicists will tell you no, and they are not wrong. The moon's gravitational pull on you is vastly smaller than the pull from nearby objects, including the person sleeping next to you or the building you're in. You imagine a physicist sighing deeply at this point, perhaps rubbing their temples. Yes, the moon pulls on the water in your body, but so does the fridge, and the fridge wins. Case closed, right? And yet biology has a habit of complicating tidy conclusions. When historians still argue whether dismissing gravitational influence outright ignores the possibility of biological amplification, systems that respond to very small, rhythmic forces over time. Here comes a quirky tidbit that keeps the door cracked open. Some studies suggest that certain cells may be sensitive to mechanical forces at incredibly small scales. Mechanoreceptors respond to stretch, pressure, and vibration. In other organisms, tiny gravitational changes influence development and behavior. Does this mean your neurons are swaying gently with the tides? No, but it does mean that too small to matter is not always the final word in biology. You settle into this uncertainty, letting the idea float rather than sink. Some researchers speculate that the moon's gravity could act indirectly, on perhaps through subtle changes in Earth's geomagnetic field or through resonance with existing biological rhythms. These hypotheses remain speculative and controversial. Historians still argue whether they belong in serious discussion or the scientific equivalent of the maybe later pile. You smile at a gentle joke drifting through your mind. If gravity were really the culprit, sleeping on a bunk bed would be a health hazard. Thankfully, it's not. The more plausible gravitational argument shifts away from force and toward timing. Tides follow predictable lunar cycles, and humans evolved in coastal environments where tidal rhythms structured daily life. Fishing, foraging, and travel often depended on the moon. Sleep, once again, followed behavior. You imagine ancestors staying awake for low tide, resting at high tide, repeating this pattern over generations. Historians still argue whether such behavioral rhythms could leave a biological imprint, but cultural habits can shape biology in subtle ways. You breathe slowly as you consider how often gravity gets blamed simply because it's mysterious and invisible. Light you can see, sound you can hear. Gravity just is. It makes a convenient suspect. Modern sleep research generally finds little evidence for direct gravitational effects on sleep. When scientists control for light and behavior, gravity fades into the background, and yet it never fully disappears from the conversation, lingering like a theory that refuses to be fully disproven. Another small smile forms as you think, gravity may not be stealing your sleep, but it's still doing plenty of work keeping you comfortably in bed. And that's worth appreciating at this hour. Your thoughts drift toward the broader idea of sensitivity. Human physiology is tuned to rhythms, heartbeats, breaths, hormonal pulses. Some systems respond best to strong signals. Others respond to repetition. Even if lunar gravity is weak, its consistency might matter more than its strength. Historians still argue whether the nervous system can entrain to such slow, subtle cycles without conscious awareness. You imagine the moon as a metronome set absurdly slow, ticking once every 29.5 days. Most of the time you don't notice it, but perhaps some part of you, deep and ancient, keeps time anyway, tapping a foot you can't feel. It's not enough to control you, just enough to be there. As the section winds down, you feel the tension between physics and biology soften. Gravity doesn't need to be the answer to be part of the story. Sometimes its role is simply to remind you how connected systems can be, even when the connections seem implausible. The moon doesn't have to yank your sleep away to influence the night. It can whisper through patterns, through history, through behavior layered over biology. You sink a little deeper, body heavy, thoughts light. Gravity does its dependable job, holding you to the Earth, while the moon does its dependable orbit, circling without concern for your bedtime. Whatever influence it has on your sleep, it doesn't demand belief. It just exists, quietly, like the pull that keeps you here, breathing, resting, drifting onward. You drift onward, and the weight of gravity slowly gives way to something more familiar. Light. Washington, not the harsh blue glare of screens or the ceiling lamp you forgot to turn off, but the softer, older glow that humans lived with for most of their history. Moonlight. It slips into the night without asking permission, and for a long time, it was the only thing that softened the dark. One mainstream historical fact anchors this shift. Before widespread artificial lighting, moonlight significantly extended usable nighttime hours, especially during full moons. Historians know this from work records, travel logs, and even legal documents noting increased activity on bright lunar nights. People walked farther, worked later, socialized more. Sleep didn't vanish. It just started later. You imagine yourself finishing chores under a silver-lit sky, not feeling tired yet because the night itself hasn't fully closed. Well, you settle into the idea that light is the most convincing suspect so far. Unlike gravity, light has a direct, well-understood pathway into your sleep biology. Photons hit the retina, signals travel to the brain, melatonin production shifts. No mystery, no speculation. Moonlight may be dim, but it's not nothing. In pre-industrial homes, where walls were thin and windows uncovered, that light mattered. Historians still argue whether moonlight indoors reached levels high enough to consistently alter sleep physiology, but the mechanism is solid. Here's a quirky tidbit that feels oddly modern. Some anthropologists studying contemporary hunter-gatherer groups found that people stayed awake later during full moons even without artificial lighting. Evening socializing increased, and bedtimes drifted later by about half an hour. No one complained. No one called it insomnia. It was just a bright night doing what bright nights do. You smile, imagining how calm sleep science becomes when it stops judging. Your breathing slows as you consider modern life. You're surrounded by light now, more than your ancestors ever dreamed of. Streetlights, screens, clocks. In that context, moonlight seems irrelevant. But researchers studying communities with limited artificial light still find lunar effects on sleep timing. Historians still argue whether this means moonlight remains biologically relevant or simply more noticeable when it's not drowned out by LEDs. You picture a spectrum of light sources, from candle to moon to smartphone. The moon sits closer to candle than screen, but it's consistent and predictable. Its rhythm might matter as much as its brightness. Honestly, some scientists suggest that repeated exposure to brighter nights at regular intervals could subtly train the brain's expectations. Not enough to override daily cues, but enough to create a monthly pattern. Historians still argue whether such training persists once artificial light dominates, but the possibility lingers. A small joke drifts through your mind. If the moon is competing with your phone for influence over your sleep, the phone is winning by a landslide. Still, the moon has seniority. You think about how light doesn't just affect when you fall asleep, but how safe and active you feel. Brighter nights reduce fear, encourage movement, and invite conversation. These behavioral changes feed back into sleep. Staying up later means sleeping less, regardless of hormones. This makes lunar effects partly social, partly biological. Historians still argue whether separating the two is even useful. Your thoughts soften as you imagine the moon rising over different landscapes. In a forest, it paints leaves in silver. In a desert, it turns sand into a glowing sea. In a city, it competes with neon and mostly loses. The moon's influence on sleep is not universal, it's contextual. It depends on where you are, how you live, and how much of the sky you still see. You breathe out slowly, appreciating that this makes the moon's role less mystical and more personal. If you live under heavy light pollution, lunar effects on your sleep may be negligible. If you live closer to darkness, they may still whisper. Historians still argue whether modern humans are losing an ancient sensitivity or simply trading it for new problems. Another gentle smile crosses your mind. Maybe the moon isn't keeping you up. It's reminding you what nights used to be like, before darkness became something we conquered instead of experienced. As Section 6 eases toward its close, light fades again in your imagination. Not abruptly, but gradually, the way it always does when the moon slides behind a cloud. You're left with the sense that moonlight, simple and physical, may explain more about lunar sleep effects than any cosmic force. Not magic. Just illumination, arriving at the wrong or right time. You let your eyelids grow heavy, feeling how even thinking about dim light makes your body lean toward rest. The moon doesn't shout, it glows. And sometimes that's enough. You drift onward. Carry gently from the glow of moonlight into the part of the story where numbers start to matter. Not dramatic numbers, no headlines screaming disaster, but small, stubborn ones that keep showing up where researchers wish they wouldn't. This is the full moon's quiet reputation. Shorter nights, slightly thinner sleep, just enough to notice if you're looking closely. One mainstream historical fact anchors this section firmly in data. Multiple sleep studies, using both laboratory recordings and wearable devices, have reported that people tend to fall asleep later and sleep for a shorter duration around the time of the full moon. The average difference is modest, often 15 to 30 minutes, but consistent enough to raise eyebrows, not once, not twice, but often enough that statisticians start clearing their throats. You imagine yourself lying in bed on a full moon night, feeling tired but not quite ready, not wired, not anxious, just delayed. You scroll a little longer, you stare at the ceiling a little more. When you finally sleep, morning arrives sooner than expected. Nothing catastrophic, just a faint sense of being cheated out of rest. Historians still argue whether this pattern reflects a true biological effect or a cultural echo reinforced by expectation and behavior. Here's a quirky tidbit that feels oddly comforting. In some rural farming communities, people historically planned lighter workloads after full moon periods, not because they feared madness, but because they noticed people were slightly more tired. No howling, no chaos, just a practical acknowledgement that sleep wasn't as deep. Imagine a world where society shrugs and says, "Yeah, this week's a bit off," instead of demanding peak performance anyway. You breathe slowly as you consider how researchers detect these differences. Sleep duration is easy to measure, sleep quality less so. Polysomnography reveals subtle shifts, but wearables now collect millions of nights of data. Some large-scale analyses suggest a clear trend. Average sleep duration dips around full moons, even across cultures and continents. Historians still argue whether big data clarifies the picture or simply amplifies noise, but the pattern keeps resurfacing. You notice how carefully scientists phrase their conclusions. They don't say the moon causes insomnia. They say sleep duration is reduced. Language matters. Reduced could mean minutes. It could mean variance. It could mean a nudge rather than a shove. You appreciate that restraint, especially when your own brain is drifting towards sleep and doesn't want anything shouted at it. A gentle joke floats by. If the full moon is stealing your sleep, it's doing it with the subtlety of a pickpocket who takes loose change and leaves your wallet intact. You think about why shorter sleep matters at all. One night doesn't change much, but patterns do. If every month includes a few slightly shorter nights, that rhythm could interact with stress, work schedules, and health. Researchers studying mood disorders and sleep vulnerability are especially interested in this. Historians still argue whether lunar sleep effects might be more pronounced in people already sensitive to circadian disruption, shift workers, adolescents, or those with insomnia. Your thoughts drift to variability. Not everyone is affected. Some people sleep through full moons like champions. Others swear they're wide awake. This variability frustrates researchers and comforts skeptics. If the moon really mattered, wouldn't it affect everyone? Maybe not. Biology is uneven. Genetics, environment, and habit all shape how sensitive you are to subtle cues. Historians still argue whether moon sensitivity is a real trait or a convenient label for normal variation. You settle deeper as timing comes back into focus. Later bedtimes explain much of the shorter sleep. Not more awakenings, not lighter sleep across the board, just delay. This aligns neatly with the moonlight and behavior story. Brighter evenings encourage later activity, even subconsciously. In a modern context, that might mean social media instead of storytelling by firelight. But the effect rhymes. Another small smile forms. The moon didn't make you open that app. It just made later feel reasonable. You also consider the role of anticipation. Full moons are visible days in advance. Even if you don't track them consciously, your environment does. Media mentions, calendars, phrases like coming up on a full moon. Some psychologists suggest that anticipation alone can shift behavior. Historians still argue whether such expectation effects can operate below conscious awareness, but placebo and nocebo research suggests they can. Your breathing remains slow as you picture the moon at its brightest, rising early, hanging long in the sky. In many parts of the world, this coincides with increased evening activity. Walks, gatherings, events. Sleep shortens not because the moon demands it, but because life expands into the night. The moon opens a window and humans lean out. You let yourself relax into the idea that shorter sleep around full moons doesn't have to be framed as a problem. It's a pattern. Patterns can be worked with. Ancestors didn't panic over it. They adapted. Historians still argue whether modern society's rigid schedules make us more vulnerable to such natural variation. As Section 7 winds down, you feel that familiar heaviness settling in your limbs. Knowing that sleep may come a little later on some nights doesn't make it less welcome. If anything, it removes the pressure. The moon isn't robbing you, it's shifting the rhythm slightly, like a song played just a bit slower or faster than usual. You let the thought fade gently, eyelids lowering, asa comforted by the idea that even a shorter night is still a night. The moon may trim the edges, but it doesn't erase the rest. You drift onward, and the numbers soften into chemistry. This part of the night belongs to hormones, those invisible messengers that slip through your bloodstream, nudging mood, sleep, and alertness without ever asking permission. If sleep is an orchestra, hormones are the quiet conductor, and tonight, the moon is standing nearby, pretending not to interfere. One mainstream historical fact grounds this section. Melatonin was identified in the mid-20th century and quickly recognized as a key regulator of sleep-wake cycles. Produced by the pineal gland, it rises in darkness and falls with light. This is textbook sleep science. What complicates things is how exquisitely sensitive melatonin is. And even low levels of illumination can suppress it. You don't need stadium lights. A gentle glow can be enough to delay its evening rise. You imagine the full moon lifting over the horizon, light filtering into bedrooms the way it did for most of human history. Not enough to read by comfortably, but enough to signal that the night isn't fully sealed. Some studies suggest that melatonin levels may rise later or peak lower around full moons. Historians still argue whether these changes are caused directly by moonlight or indirectly through later bedtimes and increased activity. Either way, melatonin seems to hesitate, as if double-checking whether it's really time to clock in. Here's a quirky tidbit that feels almost poetic. The pineal gland was once called the seat of the soul by philosophers like Descartes. Modern science has stripped away the mysticism, but not the romance. If there were ever an organ likely to get blamed for lunar mischief, this is it. You smile faintly, imagining the pineal gland glancing out the window at the moon and sighing. You breathe slowly as cortisol re-enters the scene. Often labeled the stress hormone, cortisol follows a daily rhythm, rising toward morning to help you wake. Some research hints that cortisol patterns may shift slightly during certain lunar phases, though findings are inconsistent and often subtle. Historians still argue whether these fluctuations represent real lunar modulation or normal biological noise. Cortisol is notoriously sensitive to everything: sleep, stress, anticipation. So pinning lunar influence on it is like trying to blame a single breeze for a moving leaf. Your thoughts drift toward dreams now, because if there's anywhere the moon feels at home, it's there. People have reported vivid dreams, emotional dreams, strange dreams around full moons for as long as there have been people reporting dreams. Modern studies are mixed. Some find no difference at all. Others suggest changes in REM density or dream recall. Historians still argue whether this reflects actual changes in dreaming or simply heightened awareness of dreams on culturally significant nights. You imagine yourself waking from a dream that feels sharper than usual, colors brighter, emotions louder. Was it the moon? Or did you just remember it more clearly because you woke slightly earlier than usual? REM sleep clusters toward the end of the night. Shorter sleep means you wake closer to REM, making dreams easier to recall. Suddenly, the moon doesn't need to invade your subconscious at all. It just rearranges the timing. Another gentle joke drifts through. The moon didn't give you weird dreams. It just scheduled your alarm closer to them. You settle deeper as emotion enters the picture. Sleep quality influences mood, and even small disruptions can make feelings feel bigger. Some researchers speculate that lunar-related sleep changes could amplify emotional reactivity the following day. Not enough to cause chaos, but enough to make patience thinner. Historians still argue whether this could explain long-standing associations between full moons and heightened emotion, without invoking anything supernatural. You think about how tightly sleep and emotion are braided together. REM sleep helps process emotional memories. Deep sleep stabilizes mood. If lunar cycles trim deep sleep slightly or shift REM timing, emotional texture might change subtly. Not madness, not instability, just a different shade. The moon doesn't rewrite your emotional script. It tweaks the lighting. Your breathing slows as you consider individual differences again. Hormone systems vary widely. Some people produce melatonin earlier, some later. Some suppress it easily with light, others barely at all. Genetics, age, and lifestyle all play roles. Historians still argue whether lunar sensitivity might cluster in certain chronotypes, night owls versus early birds, or whether it's evenly scattered and just hard to detect. You imagine the moon casting its glow over millions of people, each body responding or not responding in its own way. Some pineal glands shrug, others hesitate. Biology isn't democratic, it's personal. Another small smile forms. If hormones really are listening to the moon, they're doing so with selective hearing. Your thoughts drift toward the modern world again. Artificial light overwhelms moonlight in most homes. Screens suppress melatonin far more effectively than the moon ever could. This doesn't erase lunar effects, but it complicates them. Some scientists suggest that the moon's influence may now be masked, emerging only when artificial light is reduced. Historians still argue whether studying lunar sleep effects in modern cities is like trying to hear a whisper in a crowded room. You relax into that metaphor, letting the crowd fade. In quieter environments, hormonal rhythms may still register the moon's presence. In louder ones, they may not. This doesn't make the moon weaker. It makes the environment louder. As Section 8 eases toward its close, hormones step back into the background where they belong. They don't explain everything, but they offer plausible pathways: melatonin hesitating, cortisol drifting, REM timing shifting. Nothing dramatic, nothing mystical, just chemistry responding to context. You feel your own chemistry settling now. Breath steady, muscles loose, dreams waiting politely off stage. Whether the moon nudges them tonight or not hardly matters. What matters is that sleep, like the moon, works in cycles, sometimes intense, sometimes quiet, always moving. And with that thought gently looping, you drift onward, carrying your hormones with you, obedient for now, ready to do their quiet work while you rest. You drift onward, and now the night turns inward, toward that private cinema behind your closed eyes. Dreams. Well, if the moon has ever felt personal to humans, it's here, floating through symbolism, emotion, and half-remembered scenes that cling to you after waking. You don't need a study to tell you that full moons feel different in dreams. The question is whether that feeling leaves any measurable trace. One mainstream historical fact anchors this dream-heavy terrain. REM sleep, the stage most strongly associated with vivid dreaming, was identified in the 1950s and shown to cluster more heavily in the latter half of the night. This matters because timing shapes memory. When you wake closer to REM, dreams feel louder, clearer, more cinematic. Anything that nudges your sleep schedule, even slightly, can change how many dreams you remember, without changing how many you have. You imagine yourself waking a bit earlier than usual after a full moon night. Mind's still halfway submerged in a dream. Colors linger, emotions echo. You're more likely to remember what you dreamed, not because the moon scripted it, but because the timing worked out that way. Historians still argue whether reports of lunar dream intensity reflect true changes in dreaming or simply changes in recall, but recall alone can be powerful enough to shape belief. Here's a quirky tidbit that feels almost too perfect. Some sleep researchers keep personal dream logs and quietly admit that their own dream recall spikes around full moons, even when their data says nothing unusual is happening. The scientist brain and the human brain don't always agree. You smile because if anyone understands confirmation bias, it's the people who study it for a living. Your breathing slows as you consider cultural overlays. For thousands of years, dreams were seen as messages from gods, spirits, or the cosmos itself. The moon, ever present and cyclical, naturally became part of that language. In many cultures, full moon dreams were considered especially meaningful. Historians still argue whether this cultural attention amplified dream recall, making lunar dreams feel richer simply because people paid more attention to them. You drift through your own dream memories now, the ones that felt unusually emotional, the ones that stuck with you all day. You can't always remember what phase the moon was in, but you remember the feeling. Emotion and memory are tightly linked. REM sleep processes emotional material, and small disruptions to sleep can increase emotional tone. If lunar cycles shave off a bit of deep sleep or shift REM timing, dreams may feel sharper, not stranger, just brighter. Another gentle joke floats by. The moon doesn't give you weird dreams. It just turns up the contrast. You think about studies that tried to measure this directly. Results are mixed. Some find no change in dream content or frequency across lunar phases. Others report increased dream recall or emotional intensity around full moons. Sample sizes are often small. Methods vary. Historians still argue whether dream research is too subjective to cleanly answer lunar questions, or whether subjectivity is exactly the point. You imagine a lab participant being woken from REM sleep and asked to describe their dream. Words spill out, shaped by mood, memory, and personality. Now imagine that same person waking naturally at home, sunlight or moonlight touching the room. Context changes everything. The moon's influence, if it exists here, may be indirect, operating through timing, emotion, and expectation rather than content. Your thoughts drift toward nightmares because they're hard to ignore. Some people swear they have more unsettling dreams around full moons. Research doesn't strongly support an increase in nightmares per se, but sleep fragmentation can make dreams feel more intense and harder to shake. Historians still argue whether associations between full moons and nightmares reflect physiological changes or storytelling traditions that made bad dreams more memorable on significant nights. You breathe slowly, letting that intensity soften. Dreams don't need a cause to be powerful. They just need attention. And attention is something the moon has always commanded. When the sky is bright, you notice the night more. And when the night feels different, your inner world may follow. Another small smile forms. If the moon really wanted to mess with your dreams, it would be far less subtle about it. Instead, it seems content to rearrange the stage lighting and let your mind do the rest. You consider modern life again. Screens before bed reduce REM latency and alter dream patterns far more dramatically than any lunar effect ever observed. Caffeine, alcohol, stress, all louder influences. This doesn't mean the moon does nothing. It means it's part of a crowded room. Historians still argue whether lunar dream effects might re-emerge more clearly in low-tech environments where those louder influences are quieter. You imagine sleeping outdoors wrapped in a blanket, moon overhead. Dreams there might feel different, not because of lunar magic, but because your senses are engaged, your circadian system less constrained. The moon becomes part of the sensory backdrop feeding your mind as it drifts. It's not writing the dream, it's coloring the margins. Your breathing deepens as you settle into the idea that dreams are exquisitely sensitive to timing. Even small changes in when you fall asleep or wake can change how you experience them. If full moons delay sleep slightly and shorten nights, dream recall naturally increases. No mysticism required, just scheduling. And yet, because sleep science is never finished, historians still argue whether this explanation fully accounts for the emotional intensity some people report. Emotion isn't just timing, it's chemistry, memory, context. Maybe lunar effects layer on top of all three, too small to isolate, too consistent to ignore. As Section 9 eases toward its end, dreams fade gently, like scenes dissolving at dawn. You don't need to decide whether the moon touched them tonight. You only need to notice how easily belief, biology, and memory intertwine when you're half asleep. You let your mind loosen its grip, allowing dreams to remain what they are: personal, fleeting, and occasionally luminous. Whether the moon stands behind them or not, they're yours, and they'll wait patiently for you to rest again. You drift onward, and now the moon steps out of the lab and into the collective imagination. This is where culture, myth, and measurement overlap in ways that make scientists sigh and storytellers grin. Because even if the moon's effects on sleep are small, the stories humans tell about those effects are enormous. One mainstream historical fact anchors this section firmly. Across many cultures, The full moon has long been associated with changes in human behavior: restlessness, heightened emotion, sleeplessness. The word lunatic itself traces back to the Latin luna. Medieval legal texts, medical writings, and folklore all reference the moon when describing disturbed nights. This wasn't fringe belief, it was common knowledge. Sleep, sanity, and the moon were woven together in everyday language. You imagine yourself living in a village centuries ago, waking after a strange night. The moon is full, bright enough to read expressions on faces. Someone mentions they slept poorly too. Suddenly your experience feels shared, explained, validated. Why historians still argue whether these shared narratives amplified individual sleep disturbances or simply recorded genuine patterns that modern science is only now rediscovering. Here's a quirky tidbit that feels oddly modern. Emergency rooms and police departments have repeatedly investigated whether full moons increase chaos. Most large studies find no significant effect, and yet staff members often swear otherwise. Perception persists even when data disagrees. You smile softly because sleep research lives in that same uncomfortable space, where lived experience refuses to fully bow to spreadsheets. You breathe slowly as you consider why myths endure. Stories are sticky. If you expect to sleep badly during a full moon, you might notice every toss and turn more sharply. This doesn't mean you're imagining it. Expectation shapes attention, and attention shapes memory. Historians still argue whether lunar sleep myths are self-fulfilling prophecies or cultural shorthand for real but subtle biological effects. You think about how culture can act as a lens. In societies where the moon is celebrated, full moon nights may feel festive, social, extended. Sleep shortens, but it's framed positively. In societies where productivity is prized and sleep disruption is feared, the same pattern feels like a problem. Historians still argue whether modern anxiety around sleep magnifies lunar effects by adding stress to nights that are already slightly different. Another gentle joke floats through your mind. If the moon really wanted to ruin your sleep, it wouldn't need myths, it would just invent email. You notice how myths and data sometimes align in unexpected ways. Folklore often claims that full moons bring lighter sleep. Modern studies suggest reduced deep sleep. Folklore talks about restlessness. Data shows later bedtimes. Folklore exaggerates, but it doesn't always invent from nothing. Historians still argue whether myths preserve kernels of observational truth or simply recycle coincidence until it feels meaningful. Your thoughts drift to language. Phrases like sleeping under a full moon carry emotional weight. Even if you don't believe in lunar effects, the phrase itself primes a mood. Open, exposed, alert. Sleep thrives on safety and routine. Anything that disrupts that sense, even symbolically, can matter. Historians still argue whether symbolic disruption alone can alter sleep physiology, but placebo research suggests it can. You settle deeper as you consider how culture changes biology over time. Repeated patterns of behavior, staying up later once a month, gathering, telling stories, could subtly tune circadian expectations across generations. This doesn't require genes to change. It requires habits to repeat. Historians still argue whether such cultural entrainment could explain residual lunar sensitivity in modern humans. You imagine a calendar hanging on a wall, full moons circled not as warnings, but as markers. Tonight will be different. Not worse, just different. The body prepares accordingly. Sleep becomes lighter, more flexible. In a rigid modern schedule, that flexibility feels like disruption. In older contexts, it may have felt normal. And another small smile forms. Perhaps the problem isn't the moon. It's that we expect every night to perform identically. You also consider skepticism again, because it matters. Many scientists worry that reinforcing lunar myths legitimizes pseudoscience. Fair concern. But dismissing patterns because they resemble folklore isn't very scientific either. Historians still argue whether lunar sleep research suffers from guilt by association, held to higher standards simply because the topic sounds mystical. You breathe out slowly, appreciating the tension. Culture doesn't invalidate data. Data doesn't erase culture. They inform each other, whether researchers like it or not. Sleep, after all, is lived before it's measured. Your mind drifts toward how belief itself alters sleep. Believing your sleep will be bad increases arousal. Believing it will be fine promotes relaxation. The moon's cultural weight might matter less than what you think it means. Historians still argue whether reframing lunar nights as neutral or even restorative could blunt any negative effects entirely. You imagine telling yourself calmly, "It's a full moon. Sleep may be lighter." That's okay. Suddenly, the night feels less threatening. Pressure drops. Paradoxically, sleep may improve. Expectation cuts both ways. As Section 10 eases toward its close, myth and measurement begin to blur. The moon doesn't need supernatural power to influence sleep. It only needs meaning. Humans supply the rest, through stories, language, and shared attention. You let those stories soften now, losing their sharp edges. The moon remains overhead, no longer accused or defended, just observed. Whether its influence comes from light, timing, hormones, or belief, it works quietly through layers, never demanding certainty. And with that gentle ambiguity settling in, you drift onward, carrying both myth and data with you, neither fully awake, neither fully asleep, perfectly at home in the space between. You drift onward, and now the focus narrows to something so subtle you'd never notice it unless someone pointed it out. Sleep stages. Not whether you slept, but how you slept while you were unconscious and blissfully unaware of the moon doing anything at all. This is where lunar effects, if they exist, like to hide, in percentages, waveforms, and quiet shifts that don't announce themselves in the morning mirror. One mainstream historical fact grounds this part of the night. By the mid-20th century, scientists had identified distinct sleep stages: light sleep, deep slow wave sleep, and REM, each serving different biological functions. Deep sleep restores the body, while REM sleep helps regulate emotion and memory. Your night cycles through these stages repeatedly, like a tide that rises and falls whether you're watching or not. The balance matters more than the total hours. You imagine your brain during sleep, electrical activity rolling in waves. During deep sleep, those waves are slow and synchronized, a kind of neural choir humming in unison. Some studies suggest that during full moons, this slow wave activity is slightly reduced. Not eliminated, not shattered, just softened. Historians still argue whether this reduction is robust across studies or an artifact of small sample sizes, but the pattern has appeared often enough to keep the conversation alive. You settle into the idea that this kind of change would be impossible to feel directly. You wouldn't wake up and think, "Ah, yes, my delta waves were insufficient last night." Instead, you'd feel a vague residue, less physical restoration perhaps, or a sense that sleep was lighter than usual. Subtle effects leave subtle fingerprints. Here's a quirky tidbit that slips in quietly. Some sleep researchers admit that when they first saw lunar differences in slow-wave sleep, they assumed it had to be a data error. Instruments miscalibrated, software hiccup, anything but the moon. The data survived those checks. Skepticism didn't vanish, but it softened. You smile, appreciating how science often begins with disbelief. While your breathing slows as REM sleep enters the frame again. Interestingly, many studies report that REM duration doesn't decrease around full moons, even when deep sleep does. This creates a shift in proportion: less bodily restoration, relatively more dream-rich sleep. Historians still argue whether this imbalance has meaningful consequences or simply reflects a flexible system adjusting to slightly altered conditions. You imagine your body saying, "Fine, less deep sleep tonight, but I'll keep the dreaming intact," a compromise. Biology is full of them. Another gentle joke drifts by. If the moon is rearranging your sleep stages, it's doing interior design, not demolition. You think about how sensitive slow-wave sleep is to disturbance. Noise, temperature, stress, light, all reduce it. And as this makes it a likely canary in the coal mine for lunar effects. If moonlight delays sleep onset or increases evening alertness, deep sleep may be compressed simply because the night is shorter. Historians still argue whether lunar effects on deep sleep are direct or entirely secondary to timing. Your thoughts wander to age. Deep sleep naturally declines as you get older. This makes older adults more sensitive to anything that trims it further. Some researchers speculate that lunar effects on sleep stages might be more noticeable with age, though data are limited. Historians still argue whether age amplifies lunar sensitivity or whether modern lifestyle factors overwhelm it. You breathe slowly, feeling how the conversation keeps circling back to timing. When sleep starts later, everything downstream shifts. Cycles compress. Here, proportions change. REM crowds toward morning. Deep sleep gets squeezed. The moon doesn't need to reach into your brain to change this. It only needs to tilt the start of the night. You imagine two identical nights, differing only by 20 minutes. One starts earlier, one later. The second loses more deep sleep, even if total sleep loss seems trivial. Scale this across a population, and patterns emerge. Historians still argue whether this explains all observed lunar effects on sleep stages, but it explains enough to be compelling. Another small smile forms. The moon may not touch your neurons directly, but it's excellent at rearranging your schedule. You also consider individual vulnerability again. People with insomnia already struggle to enter deep sleep. For them, any additional compression may feel outsized. In a full moon night might not cause insomnia, but it could aggravate it. Historians still argue whether lunar cycles should be considered in clinical sleep treatment, but some clinicians quietly acknowledge patients who report monthly patterns. You settle deeper, thinking about how rarely we talk about sleep quality compared to quantity. You can get 8 hours and still feel unrested if deep sleep was fragmented. Lunar effects, if real, would live exactly here, in quality more than quantity, not dramatic deprivation, just slightly thinner restoration. Your breathing remains steady as you picture EEG tracings scrolling across a screen, peaks and valleys shifting just a little. To a researcher, that's fascinating. To you, asleep, it's invisible. And that invisibility is why lunar effects are so easy to dismiss. You don't feel them directly. You infer them afterward. Historians still argue whether focusing on such subtle shifts risks overinterpreting normal variability. Sleep changes night to night for countless reasons. Isolating one influence is notoriously difficult, but the moon's reliability, its unwavering cycle, makes it an unusually clean variable in a messy system. It shows up on time, every time, whether or not you're paying attention. You think about how comforting that is. In a world of unpredictable stressors, the moon keeps its schedule. Even if its influence on your sleep is tiny, it's consistent. Biology likes consistency. It learns from it. Another gentle joke surfaces. If only your work deadlines were as predictable as the full moon, your sleep would be much easier to study. As Section 11 winds down, sleep stages blur back together. You're returning to the whole rather than the parts. You don't need to monitor your deep sleep or worry about lunar percentages. Knowledge isn't meant to keep you awake. It's meant to soften uncertainty. You let your body sink a little more, trusting that even a slightly altered night still counts as rest. Your brain knows how to compensate. It always has. Whether the moon trims a little deep sleep or not, your system adapts, night after night, cycle after cycle. The waves roll on, the moon keeps time, and you quietly keep sleeping, most of it deeper than you'll ever remember. You drift onward, and now the moon's influence stops pretending to be universal. This part of the night belongs to differences. Why some people swear the full moon wrecks their sleep, while others could snooze through a lunar eclipse and a marching band. Now, if the moon really is nudging human sleep, it's doing so unevenly, like a hand that only some nervous systems seem to feel. One mainstream historical fact sets the groundwork. Humans vary widely in chronotype, the natural tendency to feel more alert in the morning or evening. This concept emerged from sleep research in the late 20th century and helps explain why early birds and night owls experience the same clock time very differently. Your circadian system isn't identical to anyone else's, and that variability matters when subtle influences come into play. You imagine yourself as a night owl, already inclined to stay up late. A full moon arrives, brightness lingering into the evening, social cues stretching the night. For you, it's easy to drift later still. Deep sleep compresses. You feel it the next day, an early bird. On the other hand, may barely notice, already asleep before the moon has much say. Historians still argue whether lunar sleep effects disproportionately affect evening chronotypes, but the logic is hard to ignore. Here's a quirky tidbit that feels almost unfair. Some genetic variants influence how sensitive your circadian clock is to light. People with certain versions of clock genes show stronger melatonin suppression in response to even dim illumination. For them, moonlight, or any light, packs more punch. You smile faintly because apparently some people are born with a turn down the moon dial and others are not. Your breathing stays slow as genetics settle into the conversation. Sleep traits are moderately heritable. How long you sleep, how deeply you sleep, how easily you wake. These tendencies run in families. Some researchers speculate that lunar sensitivity could be one such trait, unevenly distributed and therefore hard to detect in averages. Historians still argue whether this idea has enough evidence to stand on its own, or whether it's a convenient explanation for messy data. You think about sensitivity more broadly. Highly sensitive sleepers notice everything: temperature shifts, sounds, changes in routine. For them, any alteration to the night stands out. A full moon doesn't need to be powerful. It just needs to be different. Historians still argue whether reported lunar effects cluster among light sleepers simply because those sleepers notice variation more acutely. Another gentle joke drifts through. If you can feel a pea under your mattress, you might also feel the moon. You drift into the idea of expectation again, but personalized now. If you grew up hearing that full moons cause poor sleep, that belief may become part of your individual sleep narrative. Not everyone carries that story. Some people never learned it. Others internalized it deeply. Historians still argue whether individual belief systems amplify or dampen lunar effects at the physiological level, but psychology rarely stays out of biology's way. You consider gender and age next. Adolescents naturally experience delayed circadian rhythms, making them more vulnerable to anything that pushes bedtime later. Older adults experience lighter sleep overall, making subtle changes more noticeable. Some studies suggest lunar effects vary by age group, though results are inconsistent. Historians still argue whether age-related vulnerability explains conflicting findings across studies conducted in different populations. Your thoughts drift toward mental health because sleep and mood are tightly linked. People with mood disorders often show heightened sensitivity to circadian disruption. Some researchers have explored whether lunar cycles interact with mood through sleep changes, but evidence remains mixed. Historians still argue whether this line of inquiry risks pathologizing a natural rhythm or whether it could offer useful insights for treatment. You breathe slowly, appreciating how complicated this has become. The moon isn't pressing a universal button. It's tapping lightly on systems already tuned differently in each person. Averages smooth that out. Lived experience doesn't. And another small smile forms. Perhaps the moon isn't inconsistent. People are. You imagine a graph showing sleep duration across a lunar month. The average dips slightly at full moon, but individual lines scatter wildly. Some dip sharply, some barely move, some even improve. This is what makes lunar sleep research both frustrating and fascinating. Historians still argue whether focusing on population means hides meaningful subgroups who experience real effects. You think about modern sleep tracking apps now, quietly collecting individual data over months and years. These tools may finally allow researchers to see who is sensitive and who is not, instead of forcing everyone into the same average. Historians still argue whether self-tracking introduces new biases, but it also opens doors that labs never could. Yet another gentle joke surfaces. Your wearable might know your lunar sensitivity before you do, and it will absolutely not explain it kindly. You settle deeper as the idea of individuality softens the mystery. If lunar effects exist, they don't need to be dramatic or universal to matter. They only need to matter to some people, some of the time. Biology often works that way. Allergies, for example, don't bother everyone. No one demands they affect all humans before taking them seriously. You also consider resilience. Even if you're sensitive, your body adapts. 1 or 2 lighter nights a month rarely cause lasting harm. The danger comes from worrying about them. Sleep thrives on trust. Historians still argue whether educating people about lunar effects helps by reducing anxiety or harms by increasing expectation. It's like you imagine choosing calm over concern. If you know some nights may be lighter, you stop fighting them. Paradoxically, sleep may improve. The moon's influence, if it exists, loses its edge when it's not feared. As Section 12 winds down, individuality takes center stage. The moon doesn't treat everyone the same, because biology never does. Some nervous systems register the change. Others ignore it completely. Neither is wrong. Neither is broken. You let yourself sink further, comforted by the idea that your sleep is yours, shaped by genes, habits, beliefs, and yes, maybe by a pale rock in the sky that keeps impeccable time. Whatever the mix, your body knows how to rest within it. And as you drift, the moon continues its cycle above a world of very different sleepers, touching some lightly, passing others by, never insisting, always moving on. You drift onward, and the moon's role softens again. After all the data, debates, hormones, and differences, this part of the night isn't about proving anything. It's about how you feel beneath the moon when you stop analyzing it. This is where tension eases, where the moon becomes less of a suspect and more of a presence, steady, familiar, and oddly calming. One mainstream historical fact gently anchors this shift. Throughout history, humans have used the moon as a signal for rest as much as activity. Full moons marked festivals, yes, but waning moons often signaled winding down, retreat, and recovery. Agricultural societies planned lighter work during certain lunar phases, recognizing natural cycles of exertion and rest. Sleep followed those rhythms not as a problem to fix, but as a pattern to inhabit. Will you imagine yourself stepping outside at night, the moon rising slowly, not glaring, just there? Your shoulders drop. Something about seeing it reminds you that time is larger than deadlines and alarms. Historians still argue whether this calming response is cultural conditioning or an evolved reaction to predictable natural cycles. But predictability itself is soothing to the nervous system. Here's a quirky tidbit that feels surprisingly relevant. Some modern mindfulness practices encourage people to notice lunar phases as a way of grounding attention over longer timescales. Not to believe anything mystical, just to remember that not everything resets every morning. The moon becomes a monthly breath. You smile softly, appreciating how old ideas quietly rebrand themselves. You breathe slowly now, so when the moon's earlier role as disruptor begins to dissolve. If some nights are lighter, that doesn't make them failures. Lighter sleep can still be restorative. Your body isn't fragile, it's flexible. Historians still argue whether modern sleep anxiety causes more harm than any lunar influence ever could, and many suspect it does. You imagine reframing a full moon night as permission rather than threat. Permission to sleep a little differently. Permission to dream more vividly, wake a bit earlier, feel a bit softer the next day. When resistance fades, arousal fades with it. Sleep often follows. Another gentle joke drifts by, barely loud enough to notice. The moon isn't ruining your sleep. It's lowering the difficulty setting for letting go. You feel your breathing deepen, muscles loosening. Ask the moon outside, whether visible or hidden, no longer demands explanation. It doesn't need defending or debunking. It's just part of the environment your nervous system evolved within. Sometimes it nudges, sometimes it doesn't. Either way, you're safe to rest. Historians still argue whether humans once slept better when nights varied more naturally instead of being forced into identical routines year-round. There's no clear answer. But variation doesn't automatically mean disruption. Often it means resilience. Your thoughts slow, lengthening like shadows on a bright night. Analysis gives way to acceptance. Tonight doesn't need to be perfect. It just needs to be gentle. You let the ideas loosen now, no longer gripping them tightly. The moon drifts farther into the background, becoming less an object of thought and more a soft constant, like the sound of air moving through a room. Your breathing evens out, slow and unforced, each exhale a little longer than the last. You don't need to monitor your sleep, predict it, or protect it from the sky. Your body has been sleeping under the moon for as long as there have been bodies to sleep. It knows how to handle a brighter night, a lighter night, a different night. Trust settles in where analysis once sat. The moon keeps its rhythm, unbothered. You keep yours, adapting quietly. Eyelids grow heavier. Thoughts stretch, then blur. Whatever influence the moon has tonight is already accounted for, folded gently into your biology like so many nights before. There's nothing left to solve, nothing left to stay alert for. Just the steady comfort of gravity, breath, and a familiar sky doing what it has always done. You rest. You drift onward, past that soft settling, and the moon widens its reach again. Not over humans alone, but over everything that sleeps, wakes, hunts, hides, and listens beneath it. This is where perspective stretches. You're no longer alone in your bed wondering about light or sleep. You're part of a crowded, breathing planet that has been responding to lunar rhythms far longer than anyone bothered to measure them. One mainstream historical fact grounds this expansion. Many animal species show clear behavioral changes tied to lunar phases. Biologists have documented altered activity patterns in mammals, birds, insects, and marine life depending on moonlight levels. Predators hunt differently, prey hide more carefully. Nights change character when the moon is bright. This isn't controversial, it's ecology. You imagine yourself as an animal for a moment, nothing dramatic, maybe a small mammal at the edge of a forest. On a full moon night, the world is brighter, shadows sharper, hiding feels harder, movement feels riskier, sleep becomes lighter, more vigilant. Historians still argue whether early humans, who spent much of their evolutionary history in similar conditions, would have shared this pattern of lunar vigilance. The idea feels intuitive, even if it's difficult to prove. Here's a quirky tidbit that feels almost cinematic. Some prey animals reduce deep rest during full moons, not because they're tired, but because being deeply asleep is dangerous when visibility favors predators. Lighter sleep becomes a survival strategy. You smile faintly. I'm realizing how neatly this mirrors modern findings about reduced slow-wave sleep in humans. Coincidence? Maybe. Echo? Possibly. Historians still argue whether human sleep architecture retains traces of ancestral vigilance strategies. You breathe slowly as you think about ancestral humans sleeping in groups, under open skies or thin shelters. Moonlit nights would have meant more visibility, for threats and for each other. Someone stirring, someone keeping watch. Sleep was communal, flexible, responsive, not the sealed, solitary experience it often is now. Historians still argue whether communal sleep buffered lunar disruption by distributing vigilance across the group. Your thoughts drift to marine life next because if any creatures take the moon seriously, it's those bound to tides. Fish alter feeding patterns. Plankton migrate vertically depending on moonlight. Entire ecosystems pulse with the lunar month. You're not part of the ocean, but your evolutionary story began there. Some researchers speculate that sensitivity to lunar cycles is deeply ancient, embedded long before humans existed. Historians still argue whether that ancient sensitivity could persist in terrestrial mammals in any meaningful way. Another gentle joke floats by. If the moon can coordinate choral romance across an ocean, maybe nudging your bedtime by 20 minutes isn't that impressive. You consider animals that live alongside humans now. Pets often behave differently on full moon nights, more alert, more restless. Is this because they sense the moon directly, or because human routines change subtly and pets respond? Historians still argue whether observed animal restlessness is lunar-driven or socially contagious. Either way, the night feels different to more than just you. You settle deeper as you think about how humans separated themselves from nature conceptually, but not biologically. Walls, lights, schedules, all buffers, not replacements. The nervous system you carry was shaped in landscapes where the moon mattered. Even if its influence is now faint, faint doesn't mean non-existent. Your breathing remains slow as you imagine the moon as a shared signal, one cue read simultaneously by millions of organisms, each responding according to their needs. Some hunt, some hide, some sleep lightly, some don't care at all. Diversity of response is the rule, not the exception. Historians still argue whether human variability and lunar sleep sensitivity mirrors this broader ecological pattern. Another small smile forms. You're not broken if the moon touches your sleep. You're just participating. You think again about vigilance. Light sleep isn't always bad sleep. It can be adaptive, situationally appropriate. Modern sleep culture often frames any deviation from perfect sleep as a problem. Ancestral sleep was more forgiving. Some nights were deeper, some lighter. Both were normal. Historians still argue whether redefining sleep health to include natural variability could reduce modern sleep anxiety. You imagine lying in a group thousands of years ago, half asleep, hearing distant sounds carried farther in moonlit air. Someone shifts. Someone wakes briefly, then sleeps again. Where safety emerges not from unconsciousness, but from responsiveness. The moon overhead isn't an enemy, it's information. Your thoughts soften as you realize how modern expectations flatten these nuances. You expect your bed to be a bunker, sleep to be total shutdown. Any intrusion feels wrong, but biology didn't evolve for bunkers. It evolved for responsiveness. The moon's subtle influence may simply remind your nervous system of that older truth. Another gentle joke drifts through. Your ancestors didn't have sleep trackers, they had ears. You let that image fade slowly. Animals settle, the forest quiets, the ocean breathes. The moon continues its cycle, unconcerned with species boundaries or research debates. It doesn't target humans, it illuminates everything equally and lets biology decide what to do with that information. When as Section 14 winds down, you feel smaller in a comforting way. Your sleep is no longer a personal battleground, it's part of a planetary rhythm that includes wings, fins, roots, and tides. Lighter sleep on some nights isn't failure, it's context. You sink a little deeper now, body heavy, mind spacious. The moon isn't watching you, it's watching everything. And everything, including you, has learned in its own way how to rest beneath that steady, patient light. You drift onward, and the moon's glow now competes with something far more recent, far more insistent. Technology. This part of the night belongs to wrists that buzz, phones that glow, and databases quietly collecting millions of hours of human sleep. If the moon does affect sleep, modern tools are finally in a position to notice, or drown it out completely. In one mainstream historical fact anchors this shift. In the early 21st century, consumer sleep trackers and smartphones made large-scale sleep data collection possible for the first time. Instead of dozens of lab participants, researchers suddenly had access to millions of nights from around the world. Sleep moved from the lab into the wild, messy, and uncontrolled, which is both a blessing and a statistical headache. You imagine your own wrist tracker glowing softly in the dark, faithfully recording every movement, every heart rate change, every restless minute. Some large analyses using this kind of data have found consistent patterns. Average sleep duration dips around full moons, with later bedtimes being the primary driver. Historians still argue whether this reflects genuine lunar influence or simply the amplification of weak signals by massive sample sizes. Here's a quirky tidbit that feels very on brand for modern life. One data set suggested lunar sleep effects were strongest in regions with lower light pollution. The darker the environment, the clearer the moon's signature. You smile faintly because, of course, the moon shows up best when it's not competing with billboards and porch lights. You breathe slowly as you consider the strengths and weaknesses of big data. Wearables are imperfect. They estimate sleep stages indirectly. They misclassify quiet wakefulness as sleep and vice versa. But they excel at scale. Noise averages out, patterns emerge. Historians still argue whether these tools are accurate enough to study subtle lunar effects. But they agree on one thing: the volume of data changes the conversation. You think about how technology itself reshapes sleep far more than the moon ever could. Screens delay melatonin, fragment attention, and extend nights artificially. If lunar effects persist even in this environment, they must be remarkably robust, or at least remarkably persistent. Historians still argue whether the moon's influence is fading in modern populations or simply masked by louder technological signals. Another gentle joke drifts through. The moon waited billions of years to influence your sleep, only to be upstaged by a rectangle of glass. You consider how algorithms handle lunar cycles. Most sleep apps don't account for the moon at all. They optimize bedtime reminders, analyze trends, and issue stern weekly reports without ever glancing at the sky. Some researchers have begun overlaying lunar phase data onto wearable datasets after the fact, discovering patterns the apps themselves never mention. Historians still argue whether future sleep technology will personalize advice based on lunar sensitivity or wisely ignore it. Your thoughts drift to self-tracking culture. When you monitor sleep closely, you become attuned to variation. You might notice monthly dips and start attributing them to the moon. Is that insight or overfitting? Historians still argue whether awareness improves sleep outcomes or increases anxiety. For some people, data empowers. For others, it keeps them awake. You settle deeper, appreciating how technology reveals the moon's influence while also competing with it. In a sense, wearables restore something ancient: long-term pattern recognition. Our ancestors tracked the moon by watching the sky. You track it by watching graphs. Different tools, same curiosity. You imagine a future where your sleep app says, gently, "Full moon tonight. Expect a slightly later bedtime." That's normal. No alarm, no warning, just context. Historians still argue whether normalizing variation this way would help people relax into sleep instead of fighting it. Another small smile forms. Maybe the moon doesn't need to be added to your to-do list. You think again about replication and debate. Some large data sets fail to find lunar effects at all. Others do. Differences in methodology, population, and environment complicate comparisons. Historians still argue whether publication bias plays a role. Interesting findings get shared. Null results fade quietly. This is not unique to lunar research. It's a feature of science, not a bug. Your breathing remains slow as you consider how the moon interacts with modern life unevenly. Urban dwellers may be insulated from it. Rural dwellers may still feel it. Outdoor workers, campers, and those without heavy light pollution may register it more strongly. Historians still argue whether lunar sleep effects are becoming niche phenomena rather than universal ones. You imagine sleeping outdoors tonight, phone off, sky wide. The moon's presence would be unmistakable. Indoors, under layers of artificial light, it becomes optional. This doesn't mean it's gone, it means it's contextual. Another gentle joke floats by. The moon still shows up for your sleep, it just RSVPs, maybe. As Section 15 eases toward its close, technology hums quietly in the background, recording without judgment. When the moon continues its cycle, indifferent to data sets and algorithms, somewhere between them, your sleep unfolds. Part biology, part behavior, part environment, part belief. You let the graphs fade from your mind now. Numbers are useful, but rest doesn't require interpretation. Your body doesn't need a dashboard to know when to slow down. It responds to cues old and new, blending them seamlessly. The moon rises, the screen dims, the tracker keeps watch, and you finally don't need to. You drift onward, and now the tone sharpens just a little, not into conflict, but into thoughtful disagreement. This part of the night belongs to skeptics, statisticians, and the quiet hum of academic debate. If the moon's influence on sleep were obvious, this conversation would have ended decades ago. Instead, it keeps circling, and I'm much like the moon itself. One mainstream historical fact anchors this debate. Scientific consensus relies on replication. A single study, no matter how intriguing, doesn't settle anything. In sleep science, where variability is enormous and effects are small, replication is especially hard. This is why lunar sleep research remains unsettled. Some studies find effects, others do not, and neither side is easily dismissed. You imagine two researchers in neighboring offices, both brilliant, both well-intentioned, looking at the same topic and reaching different conclusions. One sees consistent patterns across datasets. The other sees noise, confounds, and publication bias. Historians still argue whether this disagreement reflects genuine uncertainty or simply different thresholds for what counts as convincing evidence. Here's a quirky tidbit that feels painfully accurate. Some statisticians joke that if you slice a dataset thinly enough, you can make the moon affect anything, including shoe sales. The point stings because it's partly true. Large datasets invite overfitting. Patterns emerge even when nothing causal is happening. Skeptics worry that lunar sleep effects fall into this trap. You breathe slowly as methodological concerns pile up. Many studies rely on post hoc analyses, looking for lunar patterns after data collection rather than designing experiments around them. This increases the risk of false positives. Historians still argue whether pre-registered lunar sleep studies would settle the issue or simply confirm how small the effects really are. You think about confounding variables. Weekends cluster around certain lunar phases by chance. Social events do too. Seasonal changes overlap with lunar cycles. Disentangling these factors is notoriously difficult. Historians still argue whether existing studies have adequately controlled for them or whether lunar effects shrink to nothing when controls are tightened. Another gentle joke drifts through. The moon may be innocent, but it keeps showing up at the scene of the crime. You consider publication bias next. Studies finding no effect are less likely to be published than those finding something interesting. This skews the literature, making effects seem more consistent than they are. Historians still argue whether lunar sleep research suffers disproportionately from this bias because the topic is inherently attention-grabbing. You settle deeper as you acknowledge the skeptic's strongest point: effect size. When even studies that find lunar influence typically report very small effects. Minutes of sleep. Fractional changes in brainwaves. Skeptics argue that such effects may be statistically significant but practically meaningless. Historians still argue whether cumulative effects or vulnerable subgroups change that assessment. Your thoughts drift to the counter-argument. Biology is full of small effects that matter when repeated. Hormones act in tiny concentrations. Neural signals are minuscule electrical changes. Size alone doesn't determine importance. Historians still argue whether lunar sleep effects fall into this category or remain curiosities without consequence. Another small smile forms. Science, like sleep, rarely settles neatly. You think about how strongly people react to the idea of lunar influence. Some dismiss it reflexively and are fearing superstition. Others embrace it too eagerly, craving cosmic explanation. Both reactions can cloud judgment. Historians still argue whether the emotional charge around the moon makes objective study harder than it needs to be. You breathe slowly, appreciating how skepticism itself is a kind of care. It protects science from wishful thinking. At the same time, openness protects it from premature dismissal. Lunar sleep research sits awkwardly between these virtues, demanding both patience and restraint. You imagine the ideal study: massive sample size, diverse populations, low-light pollution environments, pre-registered hypotheses, multi-year tracking. Expensive, logistically complex, not glamorous. Historians still argue whether the question is important enough to justify such an effort. The moon doesn't make funding decisions easy. Another gentle joke drifts by. It's hard to get a grant that says, "We think the moon might be mildly annoying." You consider how unresolved questions often linger at the edges of science. They're not central enough to demand resolution, but not trivial enough to ignore. Lunar sleep effects live here. The debate continues not because scientists are careless, but because the system is cautious. Your breathing remains slow as you realize that uncertainty doesn't have to be frustrating. It can be restful. Not everything needs a verdict tonight. Some questions are allowed to remain open, especially when the stakes are low and the nights are many. As Section 16 winds down, the debate softens. Skeptics and supporters alike fade into the background, replaced by the steady rhythm of the moon itself. It keeps circling, indifferent to arguments, shining whether anyone measures it or not. You let go of the need for certainty. Sleep doesn't require proof. It requires permission. Permission to rest even when explanations are incomplete. And with that permission gently granted, you drift onward, carrying a quiet respect for doubt and a soft acceptance of mystery, both essential ingredients for good science and better sleep. You drift onward, and now the night grows thoughtful again. Not argumentative, curious. This part belongs to the questions that keep researchers awake, staring at ceilings of their own. Not because the answers are dramatic, but because they remain just out of reach. The moon once again becomes less a claim and more a prompt. Now, one mainstream historical fact frames this uncertainty. Despite decades of sleep research, Scientists still don't fully understand why humans sleep the way they do. The basic functions of REM and deep sleep are known, but their precise regulation, why this night differs from the last, why rhythms shift so easily, remains incomplete. In that context, the moon isn't an outlandish suspect. It's one of many unresolved variables. You imagine a whiteboard filled with questions instead of conclusions. Does the human circadian system retain sensitivity to longer than daily cycles? If so, how? Is light the only pathway, or are there others still unmeasured? Historians still argue whether the absence of clear mechanisms means lunar effects are unlikely, or whether it simply reflects the limits of current tools. Here's a quirky tidbit that feels almost philosophical. Some chronobiologists point out that biology evolved in a world full of rhythms, daily, monthly, seasonal, yet modern research focuses overwhelmingly on the 24-hour cycle. The moon's month-long rhythm sits awkwardly between circadian and seasonal science, studied less not because it's irrelevant, but because it's inconvenient. You smile softly at that. The moon has always been inconvenient. You breathe slowly as open debates stack gently rather than collide. Historians still argue whether reported lunar sleep effects represent a true circulunar rhythm in humans or merely the shadow of behavior shaped by moonlight and culture. Others debate whether modern artificial lighting has erased a once meaningful biological signal. There's no consensus, just carefully worded uncertainty. Why don't you think about measurement limits? Sleep stages are inferred from surface signals, EEG electrodes, movement, heart rate. Subtle neural processes may go unnoticed. If lunar effects operate at that level, they could remain invisible for now. Historians still argue whether future technologies will reveal new layers of sleep regulation or confirm that what we see is all there is. Another gentle joke drifts through. The moon may be affecting your sleep in ways your gadgets haven't unlocked yet, and they're still figuring out how many steps you took yesterday. You drift into the idea of interaction effects. The moon may not act alone. It could interact with season, latitude, cloud cover, lifestyle, or even social structure. Small influences rarely operate in isolation. Historians still argue whether searching for a single lunar effect oversimplifies a system built on overlap. You consider how scientific questions persist not because they're unanswerable, but because they're low priority. Sleep research already competes with urgent health crises. A monthly dip of 15 minutes doesn't scream for resolution. Historians still argue whether that makes lunar sleep research trivial or quietly important, precisely because it reflects how biology handles subtle, chronic variation. Your breathing remains slow as you imagine future students reanalyzing today's datasets with better models, clearer frameworks, and fewer assumptions. Maybe they'll find nothing. Maybe they'll find a pattern that now looks invisible. Either outcome would be useful. Historians still argue whether uncertainty is a failure of knowledge or a sign that science is working as intended. Another small smile forms. Some mysteries aren't meant to keep you awake. They're meant to remind you that not everything is finished. You feel the tone soften again as the weight of unanswered questions lightens. You don't need to solve them tonight. Your nervous system doesn't demand explanations before it rests. Curiosity can coexist with calm. The moon doesn't wait for consensus. It continues its cycle, steady and indifferent, offering the same rhythm whether anyone understands it fully or not. Sleep, too, proceeds without permission from theory. As Section 17 eases toward its close, questions dissolve into background hum. You're left not with doubt, but with openness, the kind that allows rest, the kind that doesn't insist on certainty before exhaling. You let the unknown remain unknown. It doesn't threaten you. It simply shares the night. And as you drift onward, the moon keeps circling, science keeps questioning, and you keep resting, perfectly allowed to do all three at once. You drift onward, and now the moon steps out of theory and into tonight. Not as a mystery to solve, but as a condition to live with, like weather or traffic or that familiar creak in the house that only happens at night. This part of the journey is practical, grounded, and deliberately gentle, because whether the moon affects your sleep or not, you still want to sleep well. One mainstream historical fact anchors this shift toward action: sleep hygiene principles, regular schedules, controlled light exposure, calming routines emerged from clinical sleep research in the late 20th century and remain the most reliable tools for improving sleep quality across populations. No moon phase required. The basics work whether the sky is dark, silver, or completely invisible. You imagine tonight unfolding calmly. If it happens to be a full moon, you don't brace yourself. You adjust. One of the simplest strategies is also the least dramatic. Protect your evening light environment. If moonlight leaks into your room and bothers you, curtains are your friend. If it doesn't, don't invent a problem. Historians still argue whether overmanaging sleep creates more disruption than it prevents, and many clinicians suspect it does. Here's a quirky tidbit that feels oddly reassuring. Some sleep therapists actively discourage patients from checking external factors. Moon phases, sleep scores, even clocks during the night. The less you monitor, the more sleep tends to stabilize. Apparently, vigilance is not a great lullaby. You smile softly because your brain definitely didn't need another thing to track. You breathe slowly as bedtime routines come into focus. Consistency matters more than perfection. Going to bed at roughly the same time each night trains your circadian system to expect rest, even if sleep onset varies slightly. If a full moon nudges your bedtime later once in a while, the routine still holds. Historians still argue whether humans are meant to sleep identically every night, but evidence suggests flexibility is built in. Yet you think about expectations next because they're powerful and free. Telling yourself, sleep might be a bit lighter tonight, and that's okay, lowers arousal. Pressure lifts. Paradoxically, sleep often improves. This isn't denial, it's reframing. Historians still argue whether expectation effects fully explain lunar sleep disturbances, but they agree expectations influence sleep strongly. Another gentle joke drifts through. The moon doesn't need help keeping you awake. You're perfectly capable of doing that yourself. You drift into behavior. Full moons historically encouraged evening activity. If you find yourself energized on brighter nights, channel it gently. Read, stretch, write. Don't force yourself into bed like it's a punishment. Sleep arrives more easily when invited than when demanded. Historians still argue whether aligning behavior with natural rhythms improves sleep outcomes, but resistance rarely helps. You consider caffeine and alcohol because they're louder than the moon will ever be. Avoiding caffeine late in the day and keeping alcohol modest improves sleep quality regardless of lunar phase. If your sleep feels off on a full moon, check these first. The moon is subtle. Espresso is not. Another small smile forms. Blaming the moon for a double espresso at 6 p.m. is generous but inaccurate. You think about morning light now. Regardless of how the night went, getting bright light in the morning helps reset your circadian clock. This stabilizes the next night's sleep, even if the previous one was lighter. Historians still argue whether strong morning light can completely override lunar influences, but it's one of the most powerful tools available. You breathe slowly, appreciating that sleep is cumulative. One lighter night doesn't undo you. Your body balances across days. Naps, if needed, should be short and early. Long afternoon naps can delay bedtime more than any full moon ever could. Again, the usual advice applies. You imagine someone asking, earnestly, "Should I plan my sleep around the moon?" And the answer arriving softly, "No." Plan your sleep around you. The moon doesn't require a strategy, it requires context. Historians still argue whether individualized sleep advice should ever include lunar factors, but for most people, simplicity wins. Another gentle joke drifts by. If the moon needs a special plan, it will email you. It never does. You consider those nights when sleep just doesn't cooperate. Lying awake, you resist the urge to blame the sky. Instead, you get out of bed briefly, keep lights dim, do something boring, and return when sleepy. This classic insomnia advice works regardless of lunar phase. Historians still argue whether attributing wakefulness to external causes increases helplessness, but reclaiming agency usually helps. You think about anxiety now because it's the real sleep thief. Worrying about sleep is often more disruptive than sleep loss itself. If lunar talk increases your worry, let it go. You're allowed to ignore the moon entirely. Sleep science doesn't require belief. Your breathing remains slow as you imagine tonight ending, not with certainty, but with ease. The moon can be full, new, or anywhere in between. Your routine remains kind, predictable, forgiving. Sleep responds to that kindness. In another small smile forms. The most powerful sleep intervention is not controlling the night. It's trusting your body to handle it. As Section 18 winds down, practicality settles in like a blanket. Nothing here is exotic. Nothing requires tracking the sky. The moon doesn't demand attention to be neutralized. It just exists. You let the advice fade into instinct, dim lights, steady routine, gentle expectations. The rest takes care of itself. Tonight, the moon may shine or hide. Either way, you know what to do. You rest, not because conditions are perfect, but because you're allowed to rest even when they aren't. You drift onward, and the night grows quieter again, almost reflective. This part isn't about what to do or what to believe, but about what science itself is still circling, slowly, patiently. Anna, the moon hangs here as a reminder that not every question arrives with a clean answer, and not every answer needs to arrive before you sleep. One mainstream historical fact frames this pause in the journey. Many major discoveries in sleep science, REM sleep, circadian genes, the role of light, were once fringe ideas debated for years before evidence finally converged. Uncertainty is not a flaw in science, it's a phase. Historians still argue whether lunar sleep research is in its early stage or approaching its natural conclusion, but either way, it hasn't finished speaking. You imagine researchers poring over data late at night, coffee cooling beside keyboards, noticing patterns they don't fully trust yet. Sleep shortened here, deep sleep softened there. Nothing dramatic enough to headline, but nothing ignorable either. Historians still argue whether future work will reveal clearer mechanisms or quietly fold lunar effects into broader models of environmental influence. Here's a quirky tidbit that feels fitting. Some scientists describe the moon as a natural perturbation, a predictable disturbance that slightly nudges biological systems without overwhelming them. Not a driver, not a dictator, just a gentle irregularity in an otherwise steady world. You smile softly because that description feels exactly right for something that's been blamed for far more than it ever caused. You breathe slowly as unanswered questions line up without demanding resolution. Does the human brain retain a weak monthly rhythm? If so, is it biological memory or behavioral echo? Do lunar effects interact with season, latitude, or climate? Historians still argue whether these questions are testable with current methods or require new ones altogether. You think about how science chooses its battles. Some questions promise clear outcomes and practical benefits. Others linger because their effects are small, diffuse, and hard to monetize. Lunar sleep research belongs to the latter category. Historians still argue whether its value lies in the answers it might yield or in the reminder that biology doesn't operate in isolation from the natural world. Another gentle joke drifts through. The moon doesn't care if it's statistically significant. You settle deeper as you consider how modern life narrows our awareness of long rhythms. Days blur together, weeks disappear, months pass unnoticed until a calendar reminds you. The moon offers a visible counterpoint, a slow, unavoidable marker of time passing. Historians still argue whether simply noticing longer cycles could improve mental well-being by expanding perspective. You imagine someone stepping outside at night, seeing the moon, and feeling their worries shrink slightly. That feeling doesn't need a mechanism. It doesn't need data. It just needs space. Sleep often follows when perspective widens. You think again about the original question, whether the moon affects human sleep more than we thought, and realize how gently it has transformed. It's no longer a yes or no question. It's a layered one. Maybe it affects sleep sometimes for some people, through some pathways under some conditions. Historians still argue whether that counts as affecting in a meaningful sense. You suspect the answer depends on how strictly one defines meaning. Your breathing remains slow as you reflect on how little pressure there is to decide. Sleep doesn't ask for conclusions. It asks for safety, consistency, and permission. The moon's role, whatever it is, doesn't threaten those foundations. Another small smile forms. You don't need to agree with the moon to sleep under it. You imagine future conversations about this topic becoming quieter, more nuanced. Less about debunking and defending, more about context and scale. Lunar influence as one thread among many, not a headline. Historians still argue whether that future is already arriving or still a long way off. You feel the night deepening now. Questions soften. Curiosity relaxes. The moon continues its arc, unchanged by attention or neglect. Science continues its work, slow and careful. Neither rushes. Neither needs you to stay awake. As Section 19 eases toward its close, you feel a gentle sense of completion, not of answers, but of exploration. You've wandered through history, biology, culture, debate, and back to calm. Nothing is left unresolved in a way that matters for rest. You let the remaining questions drift like clouds across a bright night sky. They don't block the moon. They don't disturb the darkness. They just pass. And with that, your mind loosens its grip on inquiry, ready to slide into the final stretch of the journey. Grounded, unhurried, and quietly at ease beneath a sky that has never needed your understanding to shine. You drift onward into the last stretch, where everything slows without effort. The moon no longer needs explaining, debating, or managing. It's simply there, completing its arc as you complete this one. This final section isn't about adding anything new. It's about letting what's already here settle gently into place. One mainstream historical fact quietly frames this ending. Humans have been sleeping under the same moon for at least 200,000 years. Long before theories, studies, or arguments, there were bodies that rested, woke, adapted, and rested again. Sleep endured through ice ages, migrations, inventions, and endless changing skies. Whatever influence the moon has carried, it has never been strong enough to stop that. You imagine all those sleepers layered through time, some restless, some deeply unconscious, some waking briefly to check the fire or the horizon. The moon overhead never singled anyone out. It didn't punish or reward. It simply marked time. Historians still argue whether modern humans have overanalyzed something that was once accepted as background, but the endurance of sleep itself feels like the quiet answer. Here's a quirky tidbit that feels fittingly small. Astronauts on the International Space Station report that seeing the moon from orbit can feel strangely grounding, even though it no longer controls tides or nights in the same way. Familiarity matters. The moon calms not because it acts, but because it's known. You smile softly at that. Recognition is comfort. Your breathing slows further now, almost automatic. The many threads you followed, light, hormones, culture, animals, data, don't need tying into a bow. They can lie where they are, overlapping, unfinished, real. Historians still argue about mechanisms and meanings, but your body doesn't wait for consensus before resting. You think back to the beginning of this journey, to the idea that the moon might be affecting your sleep more than you thought. Maybe the truest part of that idea is simply awareness, noticing the sky, noticing rhythm, noticing that not every night feels the same, and that this doesn't have to be a problem. It can be a permission slip. Another gentle joke drifts by, barely there. If the moon were truly in charge of your sleep, it would have sent clearer instructions by now. You let that dissolve into quiet. The moon doesn't issue commands. It offers context. Your nervous system decides what to do with it, just as it always has. Balancing old wiring with new environments, adapting without drama. Your body feels heavier now, as if gravity has finally been acknowledged instead of questioned. Muscles loosen, jaw unclenches, thoughts stretch out and lose their edges. Even curiosity, which has carried you this far, begins to yawn. Historians still argue whether modern humans have lost something by separating themselves from natural cycles. Maybe. Or maybe you've just learned to carry those cycles inside you instead. Either way, sleep continues. That's the part that matters. You imagine the moon setting somewhere far away, unseen by you, doing what it does regardless of witnesses. You don't need to follow it. You don't need to measure it. You're allowed to rest without watching the sky. Your breathing deepens. Pauses lengthen. Words begin to feel optional. Whatever the moon does tonight, shine, hide, tug, or simply exist, it's already accounted for. Your body knows how to sleep in this world. It always has. And with that certainty settling softly, you let go completely, sinking into rest that doesn't require explanation, belief, or effort. The night holds you. The moon passes quietly overhead. Sleep arrives when it's ready.